Hi everybody, in this video we are going to see various welding defects, its causes and remedies. Now, what is welding defect or how welding defect can be defined? Simply speaking, the welding defects are irregularities in the weld metal when due to the incorrect welding parameters or wrong welding procedures or wrong combination of filler metal and parent metal. So we can define welding defect as irregularities in the weld metal. Next slide. Classification of welding defects. These are broadly classified into two groups. One is external welding defects and next one is internal welding defects. Under the external welding defects, there are many cracks, porosity, spatter, crater, undercut, overlap, imperfect shapes of weld. In internal welding defects, solid inclusion, lack of fusion, and inadequate penetration. Now let us see the first one, that is cracks. Cracks may be micro or macro size and may appear in the weld metal or base metal and or base metal and weld metal boundary. Different categories of cracks are, we can see at the top right corner given, longitudinal cracks, transverse crack, and radiating or star crack. Cracks occur when localized stresses exceeds the ultimate tensile strength of the material. This we will see in the next slide also. In the first figure, it can be seen the longitudinal cracks along the length of the weld bead and across the weld bead transverse cracks, and also in the second figure we can see the star crack. Now, what are those reasons for which all those defects occur, that will be analyzing one by one, and from that reason itself we can understand what the remedies can be. The cracks occur when localized stresses exceed the ultimate tensile strength of the material. So when it exceeds the UTS of material, then the crack occurs. These stresses are developed due to shrinkage during solidification of weld metal. So when solidification takes place, means when the weld loses its temperature, the shrinkage occurs, and due to uneven shrinkage over the entire span of the weld, from the core of the weld to the surface of the weld, due to uneven shrinkage, this crack occurs. Besides this reason, there are so many other reasons also can be. That is, those are poor ductility of base metal, high sulfur and carbon content can enhance the crack, then high hydrogen content also foster the crack, then if the cooling rate is very fast, then also crack can occur due to the temperature gradient between the core of the weld and surface of the weld. So if these are all the reasons, we can understand what the remedies can be. Opposite will be the remedies. Instead of fast cooling, it should be slow cooling process. We should ensure that hydrogen content, sulfur content, carbon content are less, and we should see that ductility of the metal, base metal, should be increased. So, and we should see that by anyhow that these stresses should not develop. Now, we are going to see what is porosity and what is the causes, what are those causes, and what are those remedies. Porosity, simply speaking, we can say it is the entrapment of various gases while solidifying the oil metal. Then it comes in the mind how the various gases are getting entrapped inside the solid oil. Before that, let us see the figure here. So porosity are shown. So these pores are evenly distributed over the entire span. Somewhere it is uniformly distributed, while somewhere it is linearly, somewhere it is cluster wise, or like worm type it is there. Next, we want to see how the entrapment of gases take place. Entrapment of gas in the entrapment of gas inside the oil takes place by various reasons. That first one may be the presence of rust, dust, oil, grease, etc. on the faying surfaces. To say faying surfaces mean the surface on which the surfaces which you are going to join by weld. So when this oil, dust, rust, etc. remains at high temperature while the welding is taking place and the molten metal is getting deposited over the surfaces, at that time this oil also burns and dust, rust, etc. burns and produces some gases. This grease burns, so produces some gases, and those gases gets trapped inside the weld and gives rise of various pores. Then also use of larger arc and current also another reason for this. Also for the gases generated can be from the flux also or coating constituents, some coating we are giving or coating is there on the maybe on the base metal, maybe on the electrode. From this coating also it can occur. Then sometimes the shielding gases we are using, that can also get entrapped. So sometimes the moisture present in the air also can get entrapped. So there may be various reasons of gases entrapping or trapping of gas. So what can be the remedy? Remedy should be that properly cleaned workpieces should be used, and we should see that larger arc current should not be used, that lowering the welding current, arc length, welding speed, etc. can be used. So if the current is less, that higher heat is not produced, so excessive high heat is not produced, So that time also that this entrapment of gases can be avoided. Now let us see in the next slide. So next slide tells about the crater. Crater, we may say simply that some small holes or pits in the weld. So what can be the reason of it? That incorrect torch angle. If the torch angles are not proper for the various types of welding procedures, then use of large electrodes, improper welding technique, etc. The reason the remedy should be the opposite one, that proper torch angle, use of small electrodes, then improper proper welding techniques, etc. Let us see the next slide. We are going to describe about the undercut. So we can see in the figure given at the right bottom corner, also at the left bottom corner, that you can see there is a gap from the oil to the top top one, that base metal. There is a gap, you can see. So this gap are looking like a drain. This drain type structure is formed during undercut. So what is undercut? Also at the left side we can see that the edges of the base metal is not touched by the molten metal or the weldment. So therefore the proper joining doesn't take place. So what is undercut? So when the undercut takes place, it reduces the cross-sectional thickness of the base metal. So if you see the cross-sectional thickness, it will reduce at these places where these gaps are there. So there will be cross-sectional thickness will be reduced. Reason? What are the reasons? First is it is excessive current. So if the current is very high, that may cause the joint that edges to melt. So you can see that in the figure A, the edges are melted. Edges may melt, and by this way that this separation from the oil to the base metal can be seen. Then poor technique of welding, okay, by which the less material deposition is taking place. So that can be another reason for undercut. Then incorrect filler metal, if it is used, if the incorrect filler metal is used, then there will be a high temperature gradient between the center of the weld and the edges. So that may lead to the undercut also. So the remedy should be the opposite. Then we are going for the next defect, that is overlap. What is overlap? So overlap, we can see that it is just lapping. It's overlapping. That molten metal in the left figure you can see, or also in the right figure also you can see that metals are getting overlapped over the base metal, but without fusion of the base metal. Means without fusion of the base metal means it is not actually making proper joint with the base metal, but it is over the surface, it is flowing. So when it is in the liquid stage, when it is in the liquid stage, that is when it is in the melted form. Reason, what are the reasons? That supply of too much oiled metal due to low welding speed. So when we go for the very low speed, so oiled metals are getting flown over the gap on through which we are intended to fill up with the molten metal. So it will be flowing over that. Then also higher welding current, also another reason. So these two must be avoided to overcome this overlap problem. Then we are going for the solid inclusion. So solid inclusion means it is the non-metallic particles getting entrapped inside the oil. Earlier we have seen that gases are getting entrapped in welding. Not only gases, also non-metallic particles also get entrapped. So where from these non-metallic particles are coming? So these non-metallic particles may come from the slag. So we are using some slag during welding. From the slag also it can be there, or other non-metallic material also may get entrapped. And as this may not be able to float, some of the non-metals which are not able to float on the surface of the solidifying oiled metal, so that will be getting entrapped and it will give the poor joint. So what are the reasons can be? Reason can be that welding current density is too small. When the current density is very small, so which is difficult to provide enough heat for the molten metal, and it leads to the fact that slag might be impossible to float. So it is when we understand in the from the fluid mechanics that when there is a totally fluid is there and fluid stays for the longer time, means the metal stays at the fluid form for the longer time. So there is a chance for the non-metal to float over that heavier fluid at the welding zone. But if the time is not there or current density is too low, then what will happen that solid inclusion may take place, because once it is getting included inside and immediately that if it is getting solidified, then what will happen, then the solid inclusion will take place. Then the if the welding speed is too fast, then also solid inclusion can take place, because if the welding speed is too fast, then what will happen, solidification will be very fast, and as the solidification is very fast, and that there is a lesser chance for floating of the entrapped slag material or some other non-metals. So therefore, if the welding speed is too fast, then solid inclusion possibilities are there. So the opposite thing should be practiced. The weld edge is not completely cleaned. If it is not completely cleaned, then also it can occur. So therefore, we should see that it is getting properly cleaned. Then welding angle and travel rate of welding rod. If they are not suitable, then also solid inclusion may occur. Then welding pool is cooled down very fast. Again, I have told earlier that if it is very fast cools, then there is a lesser chance to for the non-metal to float. Therefore, solid inclusion takes place. Slag inclusion can be prevented if proper groove is selected. All the slag from the previously deposited bead is removed. Too high or too low welding currents and long arcs, if they are avoided, then this solid inclusion can be avoided. Then incomplete fusion or lack of fusion. Lack of fusion means lack of melting actually. So it happens when the weld fails to fuse one side of the joint in the root. So we can see the figures that some of the places that roots are not getting joined. We can see at the figure A, the roots are not, at the left side, the roots are not getting joined, as because that root is not fused. B also see same. And at the seam we can see we can see that there are some misplaced weld also there, and in between the two weld there are no joining is taking place. Then so what happened, that power input, if it is very low, very low power input, then also that what happened, that it cannot penetrate properly to melt the total paying surface along the thickness. Then arc input, if it is also low, arc input, if it, as we know, heat is equal to I square RT, H is equal to I square RT. That means if the arc input, that heat input is very low, if the current is low also, then also the proper heat is not produced, then therefore therefore what happens, that that root may not be completely fused. Then another thing, that if the larger diameter electrodes are used, then also larger diameter means then the spreading of the arc will be taking place. As the spreading of the arc takes place, the deeper penetration is prevented. Deeper penetration is not done. Therefore, small diameter electrode should be used to prevent this. So, first of all, thank you all for watching this video. And if you have any question, please don't forget to share it with me. Thank you very much.